So today we're going to talk about experiments and observational studies in more detail than we have already. So let's just first start off with an example. Let's say, for instance, researchers wanted to study rabbits and a new food that they were putting on the market called Hippity Hop. And let's say the food promised that it will create shinier fur, softer fur, increase a rabbit's energy, and include 100% of the daily vitamins and essential oils. Since the study is being done with rabbits, the rabbits are experimental units, and that is because they're not human. If they were actually human participants, we would call them subjects. So the difference there is just simply if it's a non-human thing that's being studied, we call them experimental units, whereas if they're humans, we call them subjects. So let's suppose, now that we know they're rabbits, we are looking at what is actually being done to the rabbits. Well, if we're talking about what's being done to the rabbits, basically what the treatments are, those are our factors. Those are the explanatory variable that we think that will influence the response variable. And there could be different levels to factors. So for instance, we know that the factor here is the rabbit food. Well, if Hippity Hop made two different types of rabbit food, then it would be at different levels. But we can just assume for this case that the rabbits are the company has one type of rabbit food. So basically a treatment is the same thing as your explanatory variable, and it is made up of factors that can have different levels. So in this case, the factor or the treatment is the rabbit food, and the different levels could have been if the manufacturer decided to make it in two different forms, like pellets versus grains or something. The response variable is what you measure at the end. So for instance, if they're trying to measure how shiny the rabbit's fur is, then maybe they can have some expert on rabbits rate their shininess of their fur on a scale of 1 to 10 or something. So basically the response variable is just what you measure at the end to see if there was differences in the two different groups. Alright, so let's go ahead and look at an example. So in this example, a farm product manufacturer wants to determine if the yield of crop is different when the soil is treated with 3 different types of fertilizers. So 15 similar plots of land are planted with the same type of seed but are fertilized differently. At the end of the growing season, the mean yield, which just means the average growth from the sample plots, is compared. So looking at this example, we can first say whether or not it's an observational study or an experiment. Well, since there was actual treatment involved, meaning that they were giving them something other than what they were already receiving, then that makes it an experiment. So what are the experimental units here? Well, first identify the treatment here is fertilizer. So what is getting or receiving that treatment? Well, it is the plots of land. So basically the experimental units here are the plots of land. And then what are the factors? Well, remember the factors are basically like your treatment. So your overall general form of treatment here is fertilizers. And then your levels is when you state how many or what type of fertilizers there are. So it just tells us how many there are. It doesn't tell us like the actual names of the different types. So the levels here are 3. There are 3 levels to this factor. Now the response variable is what they measure at the end. So notice it says at the end of the growing season, they measure the average growth of the plots. So the response variable is the average growth. Remember, the response variable is what you measure at the end. So how many treatments are there? Well, there are 3 different types of fertilizers, therefore there's 3 different treatments. So in example 2, this one is a little bit, I think, better at explaining the levels. So we have a consumer group who wants to test cake pans to see which works best, and meaning which ones bake more evenly. So it tests aluminum, glass, and plastic pans in both gas and electric ovens. So if you really think about the experimental units here, it's easiest to think about that when you're thinking about, okay, what is the treatment? Well, the treatment they're giving are these different type cake pans. So what are they testing the cake pans on? You always think about what they're testing the treatment on, and that becomes your experimental unit. They are testing the treatment, which are the cake pans, on. If you think about it for a second, you should come up with cake batter. So our experimental units is actually different sets of cake batters, or it's just cake batters in general. So the factors are what are the treatments? What are they actually thinking will influence these cake batters? So if you notice, they are testing cake pans, so that's one factor. But also notice they're testing it in both gas and electric ovens. So the type of oven they're putting it in is also a factor here. So now we're talking levels. So well, if you look at how many type of cake pans they're testing, there are 3 different type of cake pans. We have the glass, we have the aluminum, and we have the plastic. Plastic is almost a joke. But and in the ovens, we have gas and we have electric. So there's basically 3 different levels of cake pans and there's 2 different levels of ovens. So now the response variable, think about what they're actually testing in the end. How are they going to know whether or not these cake pans worked or which one worked best? So if you think about testing these cake pans on cake batter, we should actually look to see, well, the response variable, so we need to look to see how the cake turned out. So the response variable is basically which cake baked more evenly, or which pan, I guess, produced a cake that baked more evenly. Alright, and then lastly, the number of treatments. So if you think about this for a second, we have 2 different type of ovens. We have 3 different type of cake pans. So that means in the gas oven, they're going to need to put the glass pan in with some cake batter, the aluminum pan in, and the plastic, which we should already know what's going to happen with that if anyone in here has ever cooked in an oven. And then we have the electric oven. And in the same way, we're going to need to test the glass pan in that, the aluminum, and then the plastic. So basically, you should see that there's 1, 2, 3, 4, 5, 6 different treatments that we're going to have to put cake batter in to actually see which is the best combination. So the number of treatments is 6. I'm going to just put over here. And if you notice, an easy way to get that is to just look at your different number of levels. So we have 3 levels of pans, and we have 2 levels of ovens. So 3 times 2 equals 6. So that's how you can get your number of treatments, just by multiplying the number of levels together based off the different factors. All right, so this example is from an actual study that happened. So in 2007, deaths of large number of pet dogs and cats were ultimately traced to contamination of some brands of pet food. So the manufacturer now claims that the food is safe, but before it can be released, an experiment has to be done in order to test whether or not the food is safe now. So I don't think you guys remember this, but in your guys' generation, Toyota actually had a huge recall because their pedal, the gas pedal, was accelerating by itself. So what was happening in that year of car they brought out is across the nation, these gas pedals were accelerating in these Toyota Camrys. So it was causing, obviously, car accidents, and some people died. So what happened when that happened is obviously they owed a lot of people money, but besides that, people didn't have enough confidence in Toyota Camrys to buy them because now they're worried about whether or not they're making their gas pedal well. So they had to go through a series of proving themselves in order to demonstrate, okay, well, it works now, we promise, in order to get consumers to buy their product again. Same thing in this situation. Obviously, if a whole bunch of pets are dying from eating this food, they're not going to want to, people aren't going to want to rush out there and buy the food again, even if they come out with the food and saying, hey, we changed it, it's perfectly fine now. Well, they're going to actually have to show that. So they did a study to make sure and to show that their food is now safe. Well, how could they do that study? If you really think about it for a second. So the treatment in this case, if they actually were doing a study, would have to be their new food that they're promising is better now. And they'd also need to have a second food that was already proven, maybe a different brand that's on the market that hasn't had any issues, because obviously you don't want to have some pets eating because, they want to see if their new food is safe, and then some comparing it to a group of pets that aren't eating. What would happen to the other pets that weren't eating? Of course their health would degrade, and it would appear that the other food was perfectly fine if they're just living. So the point is, you can't do anything that's going to be harmful to individuals in a study if it's going against like ethical concerns and stuff like that. But we're going to get into that more so a different day. But the point is that the other group of dogs would still need to eat something. So that would be the control group. The control group of dogs don't get the treatment. Or I keep saying dogs, but dogs and cats. So the control group is the group that you're basically comparing the treatment group against to see if there's some difference going on. And the response variable at the end, what are they ultimately going to measure to see if the food actually is safe now? Well, they're going to measure the dog's health. They have to see, are the dogs okay? Are they still alive? So it's going to be really sad for whatever, dog or cat owner agrees to be in this study or in that study. So basically, as I mentioned, the control group is basically the group of individuals or experimental units or subjects that are not getting the actual treatment. They could be given nothing, or they could be given something else, but just not the actual treatment that's being tested. So it's just something to compare the factor against. And confounding variables. Confounding variables are things that researchers need to think about that could influence the results that is not necessarily the treatment. So, for example, when we're doing research with humans, if you look at the example towards the bottom, if we're trying to figure out whether lack of exercise leads to weight gain, well, lack of exercise would be our independent variable, and weight gain would be our dependent variable. So maybe they do a study where they're measuring the activity level of different people, and then they're measuring whether or not they gain weight based off of their activity level. Maybe they're trying to see if people who don't move that much gain more weight than people who move a lot. Well, they also have to think about these other variables that could influence how much weight someone gains. For instance, age. Age is something that would be considered a confounding variable because it is something that is known to influence weight gain, whether or not how quickly or how rapidly someone loses or gains weight. So there's other things, but with humans there's lots of different things that researchers have to consider when they're testing and looking at different results. So that is considered a confounding variable. It's a variable that you can account for that can have an effect on your dependent variable or your response variable. So here's a short little video that kind of helps clear up what confounding variables mean or are.
To better understand what I mean, let's take an experiment that's been done in grade schools for generations. Let's see whether sunlight makes plants grow. You start your light growth experiment by placing one plant in the sunlight and one in the darkness, and then you wait. When you see that one of your plants is doing better than the other, you automatically assume that it's due to the sunlight, but you may be wrong. Did you accurately measure the water given to each? Or how about the soil and air temperature, or the size of the containers, and even the location? These are all extraneous variables, extra variables that may or may not interfere with your experiment. Now, if any of these extraneous variables impact your results, then we call it a confounding variable. Think of all the extraneous and confounding variables that may be present in a psychological experiment, especially those involving humans. Then you'll get an idea of why it's so important to recognize extraneous variables, especially the confounding ones.
Alright, so hopefully that explained confounding variables a little bit. Researchers want to control for those confounding variables. So for instance, if they were doing this study to see how activity influenced weight gain, well then they would want to control for age. What I mean by that is they would want to make sure they compare, certain age groups with the same age group. So that would be them making sure, okay, well we know age could influence it. Let me make sure I'm looking at people age range 20 to 40 and then I'm comparing them to another 20 to 40 group. So that's them controlling for age, so that's perfectly fine for researchers to do. What's not good for them to do is recognize, okay, yeah, we know that can influence it, but we're not going to do anything about it. We're still going to compare 20-year-olds with 60-year-olds. That's bad research. And that's why it's important that people actually look at different studies and see how they were done, because obviously we would expect a 20-year-old to, one, be more active, or two, their metabolism would be different and they could lose weight quicker than a 60-year-old. So you actually have to make sure researchers are doing their job correctly when you're reading these studies and hearing all these results they put out there. Alright, so now there's something else called lurking variables. So I think this video does a good job of showing what lurking variables are. So the only thing is, it's on this little study.com website, and they only like to show you the video once before you have to sign in. So let me see if I can go ahead and get it play once.
The goal of any research study is to demonstrate cause and effect relationships between one or more independent, explanatory, and dependent response variables. Extraneous variables are variables that co-vary with the explanatory variable and/or the response variable, making it difficult to conclude that it was the explanatory variable alone that affected the observed changes in the response variable. Lurking variables are one kind of extraneous variable. They are neither of the variables under investigation, explanatory and response variables, but some other random variables that influences one or both. These random third variables are called lurking variables because they go unnoticed by lurking beneath the surface of the variables of interest, making the relationship between them seem stronger or weaker than it actually is. Imagine a young boy on an airplane who makes an observation to his mother about the seatbelt sign and turbulence. He says, "I wish they would stop turning on the seatbelt sign because it makes everything so bumpy." Because one event consistently follows the other, the boy assumes causation, that the light coming on causes the bumpy ride. In reality, these two variables are correlated, but they are both responses to a third variable of which the boy is unaware, turbulence. A well-known relationship exists between shark attacks and ice cream sales. Both of them increase at the same time. This relationship is often used to demonstrate how two seemingly unrelated events can often vary together, which requires those who notice the correlation to consider what lurking variables might be in effect. How might you explain?
Alright, so that's actually all we needed to see on that video, so it always times out perfectly. But basically, a lurking variable is a variable a researcher doesn't think about that actually could have impacted the results. It's kind of like maybe readers read their articles after the fact and think, wow, like this is great research, but did they actually think about these things because they didn't mention them? So lurking variables are ones that researchers didn't think about. Very much like that example it showed about the boy on the plane. All he saw was those fasten seatbelt lights come on and then it get bumpy, so he just thought, wow, those lights make the plane bumpy. So instead of him knowing about this third variable of turbulence, which is the lurking variable here, because he had no idea about it, he couldn't even consider it in his head because he didn't know it existed. And the other example I gave in the video, the shark attacks and ice cream sales, well, the lurking variable there is the fact that it's hot or it's sunny. So the sun is actually what brings about both of those things. The fact of it being summer, more sharks, maybe gravitating towards that area, etc. So just to make sure we're aware of the differences, a confounding variable is basically a variable that the researcher thinks about and controls for by making sure he includes comparable groups. And A lurking variable is something that the researcher doesn't think about, basically finishes up the study, writes the report, publishes it, but maybe, readers of the research or even the researchers themselves think about after the fact, like, oh crap, maybe that actually made the results happen and not the treatment we thought would. So it's kind of like lurking because they don't really think about it at the time. It's not really something they're aware of. Alright, now I'm not sure if you guys have heard of this word before, but a placebo is a dummy treatment, or basically a fake treatment, and has no effect on the response variable. So for instance, let's say they're trying to determine whether or not a new type of Advil is effective. So they obviously have their new Advil pill. Well, they would need to create a fake Advil pill that looked exactly like it with a little A stamped on it, same color and everything, just without active ingredients, so that the two groups that are receiving those don't really know which one they're in, because there is this idea of something called the placebo effect. So we're going to watch a video on the placebo effect so you can get a good understanding of what it actually is.
In 1996, 56 volunteers took part in a study to test a new painkiller called trivaricane. On each subject, one index finger was covered in the new painkiller, while the other remained untouched. Then, both were squeezed in painful clamps. The subjects reported that the treated finger hurt less than the untreated one. This shouldn't be surprising, except trivaricane wasn't actually a painkiller, just a fake concoction with no pain-easing properties at all. What made the students so sure this dummy drug had worked? The answer lies in the placebo effect, an unexplained phenomenon wherein drugs, treatments, and therapies that aren't supposed to have an effect and are often fake miraculously make people feel better. Doctors have used the term placebo since the 1700s, when they realized the power of fake drugs to improve people's symptoms. These were administered when proper drugs weren't available, or if someone imagined they were ill. In fact, the word placebo means "I shall please" in Latin, hinting at a history of placating troubled patients. Placebos had to mimic the real treatments in order to be convincing, so they took the form of sugar pills, water-filled injections, and even sham surgeries. Soon, doctors realized that duping people in this way had another use: in clinical trials. By the 1950s, researchers were using placebos as a standard tool to test new treatments. To evaluate a new drug, for instance, half the patients in a trial might receive the real pill. The other half would get a placebo that looked the same. Since patients wouldn't know whether they'd received the real thing or a dud, the results wouldn't be biased, researchers believed. Then, if the new drug showed a significant benefit compared to the placebo, it was proved effective. Nowadays, it's less common to use placebos this way because of ethical concerns. If it's possible to compare a new drug against an older version or another existing drug, that's preferable to simply giving someone no treatment at all, especially if they have a serious ailment. In these cases, placebos are often used as a control to fine-tune the trial, so that the effects of the new versus the old or alternative drug can be precisely compared. But of course, we know that placebos exert their own influence too. Thanks to the placebo effect, patients have experienced relief from a range of ailments, including heart problems, asthma, and severe pain, even though all they'd received was a fake drug or sham surgery. We're still trying to understand how. Some believe that instead of being real, the placebo effect is merely confused with other factors, like patients trying to please doctors by falsely reporting improvements. On the other hand, researchers think that if a person believes a fake treatment is real, their expectations of recovery actually do trigger physiological factors that improve their symptoms. Placebos seem to be capable of causing measurable change in blood pressure, heart rate, and the release of pain-reducing chemicals like endorphins. That explains why subjects in pain studies often say placebos ease their discomfort. Placebos may even reduce levels of stress hormones like adrenaline, which can slow the harmful effects of an ailment. So shouldn't we celebrate the placebo's bizarre benefits? Not necessarily. If somebody believes a fake treatment has cured them, they may miss out on drugs or therapies that are proven to work. Plus, the positive effects may fade over time, and often do. Placebos also cloud clinical results, making scientists even more motivated to discover how they wield such power over us. Despite everything we know about the human body, there are still some strange and enduring mysteries, like the placebo effect. So what other undiscovered marvels might we contain? It's easy to investigate the world around us and forget that one of its most fascinating subjects lies right behind our eyes.
So hopefully you have a good understanding of what the placebo effect is. Basically, the placebo being the fake treatment itself, and the placebo effect being the thought that we must be getting better because we're taking something, not even knowing that what we're taking is not real. It has no active ingredient. It's fake. So let's go ahead and talk about how they would test a new headache medication if they were trying to put it on the market. So basically, if they had a group of 40 volunteers and they randomly assigned them into two different groups, and remember, random assignment is what researchers need to use in order to eliminate bias. So let's say you had one group of 20, another group of 20, and they gave one group the actual new pill that they're trying to bring out on the market, and then the other group, if they gave them no pill at all. Well, the reason why that would not be good to do is because, of course, the people in the no pill group would know that they're not getting a pill, and they would feel like, well, I'm not getting any treatment. Of course, I don't feel any better. Whereas the people in the new group could feel like, oh, I'm getting medication, so I must be getting better. So what they don't want when they go to compare results is basically the mental aspect to be in there of whether or not we're receiving a treatment and whether or not we're feeling better. So the better design would be to have the group of 40, randomly assign them into two groups, and then to give one the new pill and the other the placebo pill. And remember, the placebo pill is going to look exactly like the real one. So if this was a new form of Advil, they would make sure that the placebo pill was stamped with the little A, would be the same color. It just would have no active ingredients as the real one. And then that way at the end, when they go to compare, they don't have to worry about people thinking, oh, I'm not getting any treatment, I don't feel good. Both groups are receiving what looks like the real treatment, so both groups should have the same mental state when they go to report their results. So now we're actually going to watch a video where they actually do a fake surgery. If you're not familiar with knee replacement surgeries, it's a really, really big surgery that people only get when they're in dire pain and they're kind of like tried everything else and it's like the last resort. They basically go in and replace the knee. So we're going to go ahead and watch where they do a fake one and see if the placebo effect actually played a role here.
The idea was to treat people in great pain. Volunteers with severe knee arthritis were gathered from around the state and divided into groups. Two groups would have a surgical procedure. The third would be given a placebo, fake surgery. They'd have a general anaesthetic, be opened up, but wouldn't have any real procedure. They would merely think they had. I had to meet the surgeon.
It's very important for the patients not to know which treatment that they have. And they're always trying to look for clues. You know, they're always trying to get you to tell them. And the best way to avoid that, of course, is to not know as a doctor until the last minute which treatment they're going to have.
Each patient would receive a general anaesthetic, but only two groups would have an actual procedure. Not even the surgical staff knew who was in each group until they were in the theatre.
I would open the envelope in the room and I would read it, but I wouldn't announce it out loud. And then I would show it to the nurses who were working with me, and I would show it to the anesthesiologist, and nobody would ever say which of the three treatments was revealed in the envelope. We had a very elaborate ruse, if you will. I would play a videotape on the TV of a real surgery. And while I was watching the TV, I would ask for instruments and pass things back and forth and carry on conversation as if it was what I would really have done if what was happening on the TV screen was actually going on during that surgery. So we would have water splashing, we would have instruments clanking. And we would do this for the same amount of time that the actual surgery on the videotape took place, so that a patient and their family couldn't watch the clock and say, oh, we were only in the operating room for 10 minutes, so it must have been a pretend surgery.
All this acting felt a bit weird to a doctor trained in standard surgical procedures.
In the big picture, always in the back of my mind, I was thinking, good gosh, here's a patient who we're pretending to do surgery on. We're not really doing surgery, and I'm a physician and a healer after all, and is this kind of really the right thing to do, or what have I gotten myself into?
It took 2 years for the study to be completed. Finally, it was time for Dr. Mosley to hear the truth from the patients themselves.
I would say, if you think that the surgery helped your knee, I want you to give me a thumbs up. If you think the surgery didn't help your knee, I want you to give me a thumbs down. And if you're not sure or you're kind of neutral, just hold your hand flat. Twist your knee.
The verdict? Success for every group, fake or genuine. Sham surgery had worked. The patients who had it were astonished.
The response ranged from, "You've got to be kidding me, I can't believe it," bewilderment, "there must be a mistake," because they all felt so strongly that something had happened to change what was going on inside their knee.
During your training, what were you taught about the placebo effect?
Nothing. I had no clue. I went from being a skeptic to a believer. I realized that we were really onto something. There are clearly cases where we do surgeries and it's as much or more the patient's feeling about the surgery that influences the result as the actual surgery itself.
Dr. Mosley had seen patients get better purely because of what was in their minds. The pain had gone. It seemed too good to be true, and it did all happen 7 years ago. I wanted to see one of the patients who'd been in great pain before having Dr. Mosley's surgery. I wanted to know whether the placebo effect could still hold.
When I first had that pain, before that, I couldn't do a lot of things I did, like going fishing or playing basketball or going dancing. And after that, I was able to do that.
He could. Woo. We could go dancing. He took me dancing, and he could dance all night.
Can you describe what the pain was like before the operation?
Terrible, awful. I didn't think that it could be any worse.
It's emotional. Why is it because you were in so much pain before?
Yes.
And what would you say it was that really cured you? Was it Dr. Mosley, or was it you and your mind?
That is kind of a intriguing question, because I got to credit Dr. Mosley for doing what he did. But it was my mind that cured the problem.
I knew that Dr. Mosley's patients had been cured by the sham operation, but I wasn't expecting it to have changed his life. I mean, he couldn't talk about the pain that he'd experienced without crying.
So you can see from that video that the placebo effect was actually real for someone who was having a major surgery done. So some of the questions I get asked after watching that video with students is, students ask, what do you mean? Did they actually just trick them and they thought they were getting a real surgery and they didn't? Well, it really doesn't happen like that. Usually they'll find patients who are opting to get this major surgery done, and they'll approach them and ask them if they want to be part of a study where there'll be three groups of patients where 2 actually receive the the actual real surgery, and one group will not receive the surgery. So they kind of know what they're in for. They just will not know what group they're in at all, because as you heard the surgeon say, they actually go in and they cut the knee for all 3 groups of people. They open it up, they sew it back up, so the scars are going to be there for all participants, no matter which of the 3 groups they're in. It's just about after they get through their whole process, they're testing their health to see if they feel a lot better, and after that they can kind of expose them of which group they were actually in. So yeah, I mean, as you heard them say, all 3 groups, participants in all 3 groups felt tremendously better, even after, one group not having the real surgery. So, all right, that was a lot of vocabulary today, and we will pick up with a little bit more vocabulary is to come, but then we'll start looking at experiments and kind of dissecting them and seeing how they actually performed their experiment.